So hi dear, I'm Hao. This is just another video of me solving random code problem. So today we have climbing stair. You are climbing a staircase. It takes n steps to reach the top, the top. Then you can either climb one or two steps at a time. So in how many distinct ways can you climb to the top? So for combination of how you can get to the top, we have two choices here: one step and two step. So if we look at an example here, a staircase. It is me. Right? And you can, once you get to the top, you can either take one step, right? One step. So that is one way. The other way is you can go two step, right? Let's make another there to make it more interesting. So here you can do 111, right? Or you can do two step and one step, right? Or or one step and then two step, right? So 111, 21, or 12, right? So like three possible combination, right? Which is the output that we have here, right? So we can imagine that we can start at zero, right? We can either take one step or two step, right? And take if we take one step, we have two. If we take two step, we are at three. One step, we are at three. Two step, we are at four, right? So remember, n is three here. Right? If we take one step, we are at three. We take two step, four, right? So here, four is greater than three, right? So it's not valid, right? So whenever we reach three, we found our solution, right? And if it is going over, then which means that path is not valid at all, right? And so we just gonna um, return. So we just keep counting, right? And then so what is the type complexity first? Would be we have two paths, right? Two paths to two. And what is the highest? The highest n, right? So if it's n is three, we need to go like at least we need to go three level to get to the end, right? We can reduce the space complexity because we can see that we have a lot of like subtree here. Let's say for example, we can look at the another orange. Okay, we look at this subtree and this subtree, right? They are like almost they are exactly the same, right? If we are at like two, right? And it would just gonna be repeating. Even though they look small, but if the tree is like much uh larger, like if we have like 1,000 steps, it would be huge, right? So we can use dynamic programming. We can store the step that we are currently at, right? To to set time, right? So let's say if we go down from two here, so we can find only one solution, right? Only one way to get to three from two, that is plus one, right? So we can return one here. Okay, so when we see one again, when we see two again, we can just go ahead and return one instead of keep iterating down. So the maximum number of time we need to iterate through each one is twice, right? Just to end. So we ignore the constant that would be in linear time. Okay, so let's try that. Um, so we can start at zero, right? Okay, so const give us an step, or just say height for the height, right? So if height is equal to n, we return one, right? If height is greater than n, which means it's not possible to use this path, right? So we return zero, right? And then if and then we want to return the EFS of height plus one, right? And then height plus two, right? So we just test out both paths and whatever returning from this recursion, we're just gonna add them up together, right? So it is like so it is like the if you look at this would be if we so the height plus one here like would be the tree right here, right? And the height plus two, which is the rest of tree here, right? So if so we found like one result on the right subtree and two results on the left subtree, right? So we just add them up together, one and two, which is three. Right? Okay. And then as we said earlier, we want to save time, right? We don't want to keep traversing on a subtree that we already seen. We can create our memo here, right? And we can do if the height so is already in the memo. We want to just return the memo of the height, right? And we will save the result to the memo first. Apply equal to this, right? And then before we can just like return them like this. All right, let's try that. Accept it. And we have a very good runtime here. So thank you for watching.